Hello everyone, myself Pandey. I'm studying in fifth semester. Today I'm going to discuss topic about an algorithm to design finite automata, which comes under the subject theory of computations. Now let us move into the topic. Abstract. Theory of computation is always been an issue for the students to understand. This paper presents a algorithm which will simply simplify the method to design deterministic finite automata that accept strings over input symbol A, B having exactly x number of A and y number of B. Objective of the research is to make the students of method of teaching learning easier, simpler and understandable for students. In this paper, we develop an algorithm to design finite automata that accept strings over input symbol A, B, exactly x number of A and y number of B. Introduction. Objective of this paper is to develop an algorithm to design finite automata that accept strings over input symbol A, B having exactly x number of A and y number of B. In this paper, flowchart for the developed algorithm is also given, which make definitely add a level of understanding. In this implementation phase, several examples of different string sets are then of which three cases are discussed under section 5 implementation. Mythology. In automata theory, a branch of theoretical computer science, a deterministic finite automation DFA, also known as deterministic finite state machine, is a finite state that machine accepts rejects finite strings of symbols and only produces a unique computation or run of the automation for each input string. Deterministic refers to the uniqueness of the computation in search of simplest models to capture the finite state machines. McCulloch and Pitts were among the first researchers to introduce a concept similar to the finite automation in 1943. A DFA is designed as an abstract mathematical concept, but due to deterministic nature of a DFA, it is implementable in hardware and software for solving various specific problems. For example, a DFA can model software that decides which whether or not online user input such as email addresses are valid. Finite automata is defined as a set of 5 tuples where Q is a finite non-empty set of states and sigma is a finite non-empty set of inputs and S is the state transmission function. Q naught is the initial state, F is the set of final states, a possibly empty subset of Q. Reverses can be represented using either of three approaches given below: transition graph, transition function, or transition table. Now, let us move into the question. This is the question. Design a DFA that accepts strings over input symbol AB having exactly 3 A's and 3 B's. Let the resultant DFA is M is equal to Q sigma reverse as Q naught and F. Q is equal to Q11, Q12, Q13, Q14, Q21, Q22, Q23, Q24, Q31 to Q44. And sigma is equal to AB. Now reverses is given by the transition graph here. You can check into the figure. And Q11, F is equal to Q44. Now you can check the diagram. Q11 is the starting state and Q44 is the final state. Let us move into the another question. Design a DFA that accepts strings over input symbol A. Now Design a DFA that accepts string over input symbol A, B having exactly two A's and only one B. Let the resultant DFA is M is equal to Q sigma reverses Q naught and F. Now, as we know, the question is Q is equal to Q11, 12, 13, 21, 22, 23. These are the nodes, and we know the resultant node should be n plus 1, and sigma is equal to AB. Now, transaction graph is given in the figure. You can see the figure, and the final state is Q23. As you know, the starting node is Q11. It starts from there and it goes enters into Q12 as A, and Q13 also it contains A, and Q13 to Q23 the final state it goes to B, and Q11 to Q21 B, Q12 to Q22 B, and Q21 to Q21 to Q22 A, Q22 to Q23 A. This is the solution for the question. As you can see, conclusion. In this paper, we have developed an efficient algorithm which will generalize the transaction graph of finite automata that accept strings over the input symbol A B having exactly x number of A and y number of B. The algorithm will help in easy and accurate design of a transition graph of finite automata that accepts strings over input symbol A B having exactly x number of A and y number of B. Thank you.